Okay, hello everyone. Welcome to this webinar offered by Discover the Universe. Welcome to everyone who's online with me now, and welcome to all of you watching the recording. If you're new to Discover the Universe, you might have never seen me before, but I know I recognize some names there in the attendee lists. So I know some of you know me. My name is Julie, and I run the program Discover the Universe, which is a national bilingual astronomy education program. And quickly, if you'd like to introduce yourself in the chat, for those of you who are there with me live, feel free to do so. If you have questions throughout the webinar, feel free to ask them in the chat. And for those of you watching the recording, you can always contact me afterwards, and if you have questions or things you'd like some clarifications. If you are just joining, I will put in the chat again the link to access the slides. So these are Google slides. We just recently switched to Google Slides. We think they work very well because you can download them in the format you want. You can download them as PDF or as PowerPoint, or you can also create a copy. You don't have write access to it, but you can create a copy and then edit them if you'd like to use them directly in Google Slides. So we think that's a format that works pretty well. Okay, so I just told you quickly, Discover the Universe. If you haven't been to the website, or if you got the recording from someone else, feel free to check our website. We have some resources. There's actually a lot more going on in the background these days than what you can see on the website. And hopefully we'll have new stuff live very soon. We're also on social media. So if you are on Facebook or Twitter, feel free to follow us. We try to keep you updated with astronomy news and resources that you can use. And our goal is really to help astronomy education across the country. So we help teachers and informal educators, and hopefully you can get this information, feel more confident teaching astronomy, and then you can share that with your students or with your groups of kids. Sorry, I'm looking for my buttons here. I just want to mention as well our latest blog article. So you might have seen recently the new image of the black hole at the center of our galaxy. I wrote an article, a blog article about it to give you a bit of the background information, why it's so interesting. And if you had seen the other one a few years ago, we explained a bit why, the difference and so on. And I was able to record an interview with a professor at the University of Montreal, Julie Lavacek-Larondeau, who's actually a black hole specialist. She's an expert on that. So she tells you a little bit about what that means for her research. And she had some very interesting information I didn't even know about. So please check it out. It's in our news section of the website in the Astro News here. And you can see it there. Or you can just watch the video as well, which is on YouTube, but the link is from the blog article. So, but today I want to talk to you about planning your summer astronomy activities. In the past, we've offered very often a workshop at this time of the year over 3 weeks to help educators plan the summer and their activities. It was our workshop for informal educators. This year, I decided to shrink it into a 1-hour webinar, and hopefully that will give you some insight and some basic information about what to do. If you'd like to introduce some astronomy in your activities this summer, this is sort of how to get started. The Google Slides have a lot of links, so you can go back to it and link to other activities. You will see that as you browse through it. And the way I built this presentation, actually the way I was trying to imagine who the audience should be, if you're working for day camps, for example, if you'd like to do some space day or astronomy days, or summer camps or scouts and guides. So very different types of groups, in a sense that some of them will see them in the evening, other groups will see their kids during the day only. Some of them will see them once. If you're in a museum, for example, or a science center, you'll see them once. But if you are scouts groups, for example, then you'll see them regularly. So I try to take all that in mind. I was giving you ideas, but hopefully you can adapt to your own specific audience. And the way I split it, the first point is look up, get moving, and then do some crafts. So we'll cover that with a lot of links to different activities. So let's start with look up. If you're new, if you're not new to Discover the Universe, if you have seen me present before, this is something that's very dear to my heart, is to reconnect people with the sky. And by doing that, I feel we kind of reconnect with our place in the universe and with our environment as well, because we pay attention to what's outside. We look up, we look at the weather, we can see different things in the environment. just take the time to be outside looking up and sort of let that sink in. I think it's something that we don't do enough these days, and which can be quite rich for an experience. And I think it connects very well if you're, for example, scouts or guides, or if you are doing a day camp more in nature. Astronomy doesn't have to be separated from the other fields like biology or sort of, looking at the ecosystem, for example. It can be all interconnected. And this is a bit what I'm hoping that people can bring to the experience that they have with their groups of kids. And to start that, actually, I will, to sort of give you an idea of what I mean by that, there's a video I like from the group. It's kind of a weird, anyway, I'll click it in a second, by a group called Astronomers for Planet Earth. Astronomers who are worried about the state of our planet, especially when it comes to climate change. And they've created some very interesting videos. And I love this one so much, actually, that I collaborated with them to do it in French as well, so I could show it in both languages. But we will take a few minutes to watch this one in English. So there we go.
Humanity has always had a special relationship with the stars. Human beings' talent of pattern recognition allowed us to see patterns in the night sky, which not only informed our decisions about navigation and the seasons, but also inspired our stories and myths about creation. All over the world, different peoples looked up at the night sky and used the stars to tell each other stories about who we are and why we're here, as well as to simply entertain one another, which all helped to build their own unique cultures. Throughout history, wandering peoples of different nomadic groups would use the stars to help guide them through different lands. And when human beings took to the seas, the stars became even more important for navigation. One way or another, the starry night sky was always a meaningful part of every human's 24-hour cycle. Then, in the 20th century, much of humanity's relationship with the night sky began to change. As the Industrial Revolution really got underway, the light pollution from cities around the world began to obscure people's view of the stars. Human beings started to more heavily rely on technology to help them navigate the world, as well as to tell stories and entertain each other. Many lost their relationship with the night sky, and along with that, a large part of their connection to the natural world. And with that loss of connection came environmental destruction on a scale never before seen. So much so that human beings began to affect and change the very atmosphere in which we live and breathe, the delicate veil protecting us from the harshness of space. So now, as we use our amazing technology to view the stars and the other planets in our solar system and beyond, what can this newfound knowledge teach us about what we are doing to our own planet? What can Venus's runaway greenhouse effect teach us about Earth's greenhouse effect? What can the loss of Mars's habitability teach us about the continued habitability of Earth? What can our biological, chemical, and atomic connection to the stars teach us about the universe and ourselves? Can we reconnect and repair our relationship with not only the stars, but also the natural world?
So if you want to watch this video again, the link, you can link to it directly from the Google Slides. I hope you like it. I really do, actually. I think it's a very powerful video to start the discussion, for example, on, looking up at the sky and observing the sky. And actually not just that, but also the connections of what can our new knowledge, how can astronomy help us, make the world a better place as well. So I talk a lot about observing the sky, but when you do that, if you go outside and you don't know anything about a sky, it can be a bit intimidating. So how do you start learning the sky, understanding patterns, for example, learning the constellations, how to identify what you're observing, for example, is it a planet or a star? Well, you can observe regularly. This is really the basics because things change in the sky. There are some cycles. It makes sense to try to observe as often as possible, and then you'll start noticing things. However, that means it takes a lot of time. You also need good weather. I mean, you don't need to observe every night, but actually I know these days in Quebec, it's been really bad in the last little while for observation. It's been really hard to observe. So weather is obviously an issue for many of us in Canada. So thankfully, there are some tools which you can use. And actually, these tools can also be very good educational tools. So for yourselves, to learn the sky, but also as an activity you can do with the kids. So let's start with the star finder. So if you don't know what a star finder is, it is, well, I have this version right here. And actually, I don't see myself. For some reason, my camera has disappeared from my field of view. So I don't know if I have it in the right field of view, but anyway, you can see it there. What you need to do, I'll point on the screen instead, is that you can align like these two parts. This part can rotate. It's kind of stuck. There we go. This part can rotate here. So if you look at the screen, you can align the date and the time at which you're observing. And then the part of the sky that's visible here in the window will be what's above your head on that night at that time. But what's fun with the star finder is that, well, it's something you can build. So you can print it, for example, have the students cut them. And in our guide, which I wrote a few years ago called Looking Up, there's an activity idea on how to use it, well, in the classroom, but it can also be in any other setting with some questions, sort of to have kids learn how to use it, what's in it, what can we actually see on that map. For example, what does it mean? How does the sky change over a few hours or night after night or at different times of the year? And I created a short video tutorial as well to show how you could use it if you go outside. Because this is a great tool to use, with the groups in front of you. But this is really an observational tool which you can use outside. If you're planning on using it to learn the stars and constellations, I recommend buying a plastic version from most bookstores. It will last longer when it gets humid, let's say outside. But the paper version is great as a first, tool to learn the sky. And actually, I want to mention that you can look at it in our Looking Up module, but I collaborate closely with the Dunlap Institute, and they actually have free star finders. They've had some for just a bit before the pandemic. Then they stopped shipping them during the pandemic when everyone was working from home, but they've started doing that again. And I really like their star finders because the star wheel has two sides, and it's probably hard for you to see through the webcam, but if you go to the website, you'll see one side has more stars and the other side has less stars. So it more closely represents what you would see in a slightly light polluted area. Of course, if you're in downtown Toronto, it's going to be harder. And then the dark side has a lot more scientific information as well, and different celestial objects identified in it. So if you'd like some, you can order some for free for your whole group. You'll just have to click on that link once you get to the Google Slides. So again, this is a great, I can imagine like with scouts and Girl Guides, for example, this could be a very good activity to do in the evening. And then hopefully it's clear afterwards and you can observe the night sky and try to use it for real. If you're under the real sky, I highly recommend using a red flashlight to light your star finder. Red flashlights don't affect your night vision as much. So you would be able to see what's on the paper and also observe the stars without being too blinded by the bright light. So this is the paper version. Now we have technological tools which are fantastic, and I will show you quickly how to use Stellarium. So there are many planetarium programs. They are very useful, as I just said. Stellarium is the one I recommend the most. It's free. The downloadable version is available in multiple languages, which is great, and it can show the constellations and the mythology from many different cultures. So usually the ones we represent are the ones from the Greco-Roman mythology, but any other constellations are just as valid in the sense they're all invented anyway. So it's great to maybe go away from the Western constellations and show other cultures and their knowledge of the sky as well. The web version, which is the one I'll be showing you, is great because it works directly in your browser, but it has less options. There's also a mobile app, which I believe might be free now, but you might have to pay for add-ons. But it's very useful to have those on your smartphones as well, because if you go outside, you can sort of, if you know where, if you're pointing at the sky with it, it will tell you what's in that direction. So it really helps you identify what's out there. Now, you might think with apps like that, then there's no point having the paper version anymore, but I still think there's value in it. That's why I still recommend it, especially for an activity to get the kids, to learn a bit about the sky and how to use something like this. So I will take you on a quick tour of Stellarium Web. So again, if you go to Stellarium Web, this is the view when you start, and I highly recommend just clicking on that right away so you have a bigger field of view. And this is the sky today. It's actually showing me the sky tonight. And it's kind of weird. It always finds me in a different place. So this is supposedly where I am located. It always says something different when I go there, which is kind of strange. But anyway, you have to click here to make sure you are in the right place. So if the cursor is not where you live, make sure you drag it somewhere else. When you use auto location, and then when you use auto location, it should figure out where you are from your IP address, but you can always move the cursor if you need to. And it doesn't have to be, I guess, depending on your goal, it doesn't have to be extremely precise. For example, if I had the sky from Montreal, it would still, which is 200 kilometers away, it would still give me a pretty good view of the night sky. But if I wouldn't want to have be located in Mexico, that would be completely different what I would see in the sky. And yeah, so you can change the time at which you want to observe. I can go back to right now, but right now is daytime, so it's not as interesting. So it's kind of nice to go in the evening. Actually, I'll move west a little bit. So we're looking west here. And if I drag this, and you can see how, sun sets, it gets dark very late at this time of the year. And you can see the moon right here. You can see some satellites as well. We see more and more satellite. This is a Starlink satellite. We might see a whole line of them actually. Oh yeah, there's the other one. And that's another one. So yeah, there were more and more satellites. Unfortunately, that's actually an issue for astronomers right now. You can zoom in, so we can have a look at the moon. You can click on it. For some reason, it's not selecting it right now and you could always center it like this as well and zoom this way if you wanted to have a look at it. So that's always kind of nice. You can add constellations. I realize my field, hold on, let's do this way. You might see better. So you can add constellations. You can add the drawings of the constellations as well. Here's one you might recognize. Here's the Big Dipper, which is actually part of Ursa Major, and here's the Big Bear. So if you ever wondered where the Big Bear was, here it is. It doesn't look, the constellation itself, to see the bear, you need more stars, which are already faint. So most people just recognize the Big Dipper in it. So yeah, there are quite a few options with it. I recommend you try things, and I will just remove the constellations art to show you a few of the main stars and constellations visible in the summer. So the first place to start, very quickly, I'll give you a tour in a few minutes of the tour of the night sky. You don't need to know all the stars and constellations to get started. Actually, it would be overwhelming. And this is a bit tricky, I find, when I've done the activity with a star finder, is that people try to learn everything that's on there. That's why I kind of like the version from the Dunlap Institute, which has less stars on one side, because to be honest, I've never really found the links in the sky. I've never looked for it in the sky. I know enough stars and constellations around that I don't need to know every single one to find my way across the sky. So in the northern part of the sky, let's say tonight, it's late at this time of the year, but that would be the sky you would see later this summer around 8 p.m., for example. If you start with the Big Dipper, let's go this way. So the Big Dipper is here. If I use the two stars here, which are opposite to the handle, if I draw a line between them and extend that line, I would find Polaris, the North Star. And Polaris always points directly north. So obviously that's a good way to orient yourself. That could be a great discussion to have with groups outside at night as well. How do you orient yourself at night? Finding Polaris, North Star is obviously the best tool. Polaris is part of Ursa Minor, the little bear. So that's another constellation here, although this one is quite a bit harder to see. The 4 stars here are quite faint, and it kind of curves back towards the handle of the Big Dipper. And another constellation you can see all year round, because these constellations here are what we call circumpolar constellations, which means they're visible all year round. They go around the pole, they go around Polaris. That's what circumpolar means, and you can see them all year round. So if you start with the Big Dipper, you find Polaris, and then on the other side, let's say, for example, if you start with the handle of the Big Dipper, you have Ursa Minor, and then you continue on that direction, you have the W of Cassiopeia right here. Right now it's a W. In 6 months, it's going to be more like an M in the sky, but it's relatively easy to find as well. So I just wanted to highlight this one. Now let's look east. At this time of the year, we have the summer triangle. Summer triangle is actually made of 3 stars, which are quite bright, but it's not an official constellation, part of the reference constellations we use, like based on the Western mythology. So we have Vega right here, Deneb, Insignis, the swan, and Altair here, part of the Aquila, the eagle. And these 3 stars are what we call the summer triangle. Right now, they're relatively low in the eastern sky still. But for example, if I go, let's say mid-August, it will be very high in the southern sky. Here's a summer triangle. So after sunset, there would be some of the first stars to appear, and this can help you identify them. Let's go back to tonight, just to tell you a bit more in that order, like starting at this time of the year, if you want to learn the sky a little bit. So summer triangle, below the summer triangle is a small constellation I like. It's the Delphinus, the dolphin. It looks a bit like a diamond with a tail. Look at that. Look at all those satellites. It's crazy. There's so many now. So yeah, there you go. That's Delphinus, the dolphin, which I like personally, and it's below the summer triangle. Now, if we move further in the south, actually, let's skip these constellations for now. Let's look up a little bit. There are some big constellations here like Ophiuchus, but it's not easy to recognize. I wouldn't recommend using that as a reference system. Let's go back to the Big Dipper. Earlier, we were looking at it more towards the northwest, so it looked like this. Now I'm kind of turning towards the western sky. And instead of using the pointers here to find Polaris, we're going to use the handle, which curves like an arc, and you follow the arc to Arcturus. That makes it easy to remember. And the trick is actually you follow the arc to Arcturus and you speed up to Spica right here. Get confused with the moon there, but Spica is another bright star in the constellation Virgo, a bluish star, while Arcturus is more of it's a red giant star actually, so it appears a bit orange to the eye. So you have Arcturus and Spica right here, 2 stars you can identify in the western sky tonight. Arcturus is part of Boötis, and Boötis I think looks a bit like an ice cream cone, and I really like Corona Borealis, another small constellation next to it. And I like to say that this is the smile of the kid eating the ice cream cone. It's kind of easy to remember that way. So this is in the western part of the sky, actually quite high in the sky. And I just want to highlight the 2 constellations here that are quite low, but I like them, maybe because they're a challenge. We only see them during a few weeks of the year. If I go, let's say in 1 month, okay, let's try that. Again, late in 1 month, but you would have Antares, the heart of the scorpion. For some reason, I can't, there we go. Antares right there, which is another reddish star. And this is Scorpius, the scorpion. From Canada, it's hard to see the tail here because it's very low on the horizon. And if you're further north, actually in Canada, you wouldn't be able to see it. But this is a nice part of the sky. There's a lot of nebulae and star clusters because they're actually, oh, you can't see my cursor? I'm sorry, I just noticed that. Well, this is a bit annoying. Not very useful as I'm pointing things. Okay, I'll click on things. Hopefully that will change. I just noticed that I did the whole webinar in French like that without knowing that people couldn't see what I was doing. Sorry about that. I'm showing you, I highlighted here. Oh, hold on. Now, can you see it? Because now, okay, spotlight. No, hold on, sorry. I'm gonna try to, now you can probably see that. Oh, it's visible, but not, oh, okay, it's not perfect. Well, anyway, like this, hopefully that you'll see a bit better, but it's weird. I'm surprised it's not working super well. Sorry about that. I'll watch the recording, see how it shows, and then adapt next time. So yes, this region of the sky here is actually towards the center of our galaxy. When we see the Milky Way, actually, hold on, if I remove the atmosphere, there we go. Now we can really see how dark the sky can be, and you can see the center of our galaxy. And in fact, the black hole, the picture of the black hole that we saw recently, like that black hole is located in that direction, about 26,000 light years away. So it's kind of nice if you talk about black holes to your groups and you point in that part of the sky and say that's where it is at that distance. It's kind of fun to connect it that it's actually somewhere in space. We can point to a direction and show it. And Sagittarius looks a bit like a teapot with the handle right here and the spout. And always imagine the center of the galaxy as sort of the smoke, not the smoke, but the vapor coming out, the steam coming out of the teapot right here. Again, these constellations are only visible for a few weeks or months in the summer, depending on how late you observe. So it's kind of nice to see them. Okay, I guess I still have that. So that's a very quick tour of the night sky. And I like that you can, again, change time, see how the sky changes night after night or months after months. Could go on your birthday. I just want to highlight that this summer we will have some planets, but it'll be quite late. It will be better in the fall, unless you want to observe, but with kids, it's kind of hard to observe at 11 or midnight. But later on, we will have, let's say if I go in September, earlier in the evening, we will have, at more decent times, we will have Saturn and Jupiter will be extremely bright in the sky. It will really stand out. Saturn will be bright, but not as bright. I didn't highlight the right thing. So Saturn will be there as well in Jupiter, but that's more in the fall. I think for the summer, it will be quite hard to see them. They'll be quite late. So that's a bit what I wanted to highlight in Stellarium, give you an overview of the main stars and constellations. Of course, that's a lot thrown at you at once. You can always go back and watch the recording, but I will come here and just show you, I made a list of the summer stars and constellations, so I'll add the S afterwards. The ones I just highlighted here with some information or notes about them. If you want to remember which ones are the ones you should focus on to learn right away or learn as you start, the first ones you should learn for the summer sky. But again, even if you're not seeing your groups at night and you can't show them the real sky, I think there's value in becoming more familiar with it, and then you can definitely talk. I don't go outside with a group in the evening a lot anymore, but I like that I'm able to reference or give them some references or talk to them about the sky because I know it. And I can, I can understand how things work and so on. But now let's talk about some activities. Like I said, let's look up, let's do some activities outside. The daytime moon, if you're during the day, if you don't have your groups at night, seeing the moon during the day is something that's quite nice that people tend to forget. The moon is visible in the daytime just as much as it is in the nighttime, almost, because there's like a few days we don't see it for a new moon. But other than that, it is there quite often during the day. We just don't see it because we don't pay attention to it. And because the phases are it's usually smaller phases, right? So they're thinner, they're harder to notice. But there are some activities you could do during the day while you have the moon out there. First of all, just like mention it to your students. I talk about the phases of the moon. But I really like this activity, which is super simple, but you take a little ball. And I like some of the balls that work the best are the little styrofoam balls you can buy in crafts sections of dollar stores. I don't like that styrofoam. It's not the best for the environment, but at least if you reuse them often, they can last for a long time. And the way they reflect light works very well for this activity, because if you hold this ball under the real moon in the sky, you will see the same phase that's lit with the sun. Of course, it needs to be sunny. So you need to see the sun and the moon at the same time on a sunny day. And you will see the same phase on your ball as you will see in the sky. And this is a bit what we see here. We have a crescent moon in the sky, and we can see a crescent moon on the moon ball of this little, of this kid here. And I've done this at the college level, and my students kind of had an aha moment when they realized, oh, this is how it works, right? The moon is always there. It's always a sphere. It's kind of obvious, but when you don't pay attention to that, it gets a bit confusing why we only see half of it sometimes. So the moon is always there. It's always a sphere, but we don't see the full lit section of the moon. And that's why we have phases. So this is something very simple, but it works very well. Try it for yourself first, and then you could try it with a group. And again, this is an activity in our guide, so you can go check it. So I've put down here the phase of the moon, which you can see during the day in the summer. So visible in the afternoon and early evenings is the first quarter moon. That was the case. Was that yesterday? 2 days ago? No, yesterday. 2 days ago, sorry. And then it's in a month again, July 7th, and then August 5th and September 3rd. The last quarter moon is actually visible in the morning. So again, this is, even if you don't observe on those days precisely, it should be visible, a bit before and a bit after those days, but at some point, it doesn't change like suddenly, but it will shift. The time will shift until eventually you won't see it in the morning anymore. So if you want to make sure the moon will be visible during the day you want to do the activity, you can always go in Stellarium and check, put the exact date and time when you want to observe and see if the moon is visible, for example. But I put the ones when the face would be visible in the morning, I've put them here. And I love this table. Actually, this is from the Moon Gazer's Guide, which is a guide like this. You can actually buy from the Royal Astronomical Society of Canada. And if you have events, that could be something interesting. You have the moon, and it highlights the main craters and the main Maria, like the darker parts on the moon. And on the back is where you have this table. And I really like it because when you become very familiar with the phases of the moon, you know when it will be visible. But as you start, this is way too much information. But if for example, if you take the full moon, well, the full moon will always rise at sunset. It will be in the eastern sky early evening, or the first part of the night, the evening part of the night. It will be highest in the sky at midnight, and then it will be in the western sky early morning, and it will set at sunrise. So the full moon is exactly opposite to the sun, but that's not always the case. The moon can be there during the day, right? The waxing crescent will be there like morning and just afternoon and just after sunset, for example. So it is visible for most of the day as well. So this could be useful, especially these days. If you look at any calendar, or if you type online like phase of the moon today, you can get the information pretty quickly about what phase of the moon is today. And I won't go into too many details about the phases of the moon. This is a picture you can use again to explain it. But basically we have the Earth, the moon in 8 different places in its orbit, and it goes around the Earth like this. And we have the sun far away. So there's always a daytime side on the moon, and a nighttime side, a night side of the moon, just like the Earth, daytime, nighttime. And from Earth, though, from where we are located, we don't always see the full lit side. It's only when it's here that the Earth is facing the lit side of the moon, so we see a full moon. But other than that, sometimes we have a crescent, a quarter moon, a gibbous moon when it's more than half, full moon, and then we have the reverse phases or the waning phases on the other side. So if you'd like to learn more, I put a video that actually I created a few years ago for a workshop, and the PowerPoint presentation for it, and that activity as well to talk about the phases of the moon. But you can you can click on that to learn more in the document. Now, if you have people with you in the evening, you can, as I showed you in Stellarium, you could look at the stars, but depending on the quality of the night sky, it might be tricky. If you're close to a city, you will have a lot of light pollution. So the moon is your best friend because it's visible in a rural area, very dark sky, or in a city as well. So again, if you want to do it in the evening, the waxing phases of the waxing crescent, what's getting bigger, waxing quarter or first quarter, and the gibbous moon, they'll all be visible in the evening. And this is a time, if you have binoculars, again, people tend to forget binoculars, but you don't need a telescope to observe the moon. You could use binoculars, and it's actually very nice to see the craters a bit more on there. So again, with the naked eye, it's great to observe as well, but if you have some instruments, then you can try that, and you can have some discussions and activities about the moon. If you know you're meeting your group on a night where the moon is visible in the evening, pay attention to that, and that could be a good opportunity to do an activity about the moon. You can also wait until full moon because it rises at sunset. So you could actually watch the moon rise. You observe the moon rise, and that's very interesting to see it rise above the horizon. And it always looks huge on the horizon, but it's actually quite small. This is what we call the moon illusion. And one thing I like to recommend to people is if the moon looks this big to you on the horizon, extend your arm, and actually your fingernails will be enough to cover the moon. So it looks kind of weird when we do that on the side of the road or wherever you are, but just to prove to yourself that you can cover the moon with your finger, try it. It's never that big on the horizon. So you could try that when it's full moon. And of course, it's very bright and beautiful. And the full moon is actually better to observe with the naked eye. Like you don't need instruments to observe it, in the sense that it will be so bright anyway through binoculars. You could try it, but it's not necessarily the best time to observe the moon because there's no contrast. It's fully lit. You don't see the craters as well. So just observing it with the naked eye it's a good time to do it. Now I want to mention as well in the evening sky, meteor showers. Sorry. Meteor showers, if you have groups during the evening and if you're going to be spending hours with them under the night sky, then if you have to pick a time in the summer, pick the times around August 12th, because that's when you have the Persean meteor shower. And this is the easiest activity you can do with a group in terms of observing the sky, because you just lie down to see as much as the sky as possible. You don't need any instrument. Actually, you don't want to use an instrument because you want to use your eyes to view as much of the sky as possible. And depending on where you are, if you have some lights, some street lights or some lights around you, try to observe away from the lights. And if possible, give some time to your eyes to adjust, for your eyes to adjust to the darkness, so you will see more shooting stars. But this is always a lot of fun to do with a group. Then you're just quiet under the stars, then suddenly everyone gets excited because they just saw a bright meteor, and that's always very fun. So why do we have meteor showers? Well, a shooting star or a meteor is actually a very small piece of dust or a grain of sand, for example, falling into the atmosphere of the Earth. And what happens is that at certain times of the year, the Earth enters a dusty region in its orbit around the sun. So you have more meteors. So more of them will fall into the atmosphere, heat up and create the light phenomenon that we call the meteor. And why do we have dusty regions in our orbit around the sun? It's because there are some comets that didn't necessarily pass this year. They might have gone by a long time ago, but they left a lot of dust in their paths. And when the Earth crosses that path, then suddenly we get a meteor shower. And that's why at the same date every year, we enter the same region of space, and then we get a meteor shower. So this drawing is obviously not to scale. We wouldn't want little things that big hitting you because it's like those dust grains are actually quite big on the scale, but the Earth goes around the sun like this, and then let's say every August 12th it comes back to the same place, which happens to be crossing the path of this comet, which went around again not necessarily in the same year. They just showed it here to show that that's what caused the dusty region, and it went around and it left a lot of dust. So that's why we have meteor showers. And there are many of them throughout the year. The Perseids around August 12th is one of the best. So depending on your location and the conditions, you could probably expect to see about 1 meteor per minute or 60 something per hour. But as you can see, the Geminids in December are almost as good, but maybe you didn't know about them because probably it's, we don't tend to spend a lot of time outside in December just looking up like that. It's really, watching meteor showers really something that it's not like you go outside for 5 minutes, you do it and you come back. It's spending a lot of time outside, just enjoying the view and try to see as many as you can. So let's talk a bit about some of the seasons and before getting into the activities for moving and the crafts. I find that season transitions, like the solstice coming up on June 21st, or the fall equinox in September, I find that there are very good times to talk about astronomy, the sun, motions of the earth, especially in summer. I know this is right at the end of the school year for many, but if there's an occasion to sort of celebrate the summer solstice, I think there are many activities you could do then, especially, again, if you are in a nature interpretation center or something like that, to talk about how we get our energy from the sun and what changes, throughout the seasons with the impact on plants and animals. You could have some activities that day about measuring your shadow at different times of the day, or if you have groups that you see often in the year, you can measure the shadow at the same time on different days of the year as well and see how it varies. You could really get into the inclination of the earth and the reasons for the seasons. I won't go into the details now. Or even you could, if it's possible, you could do some safe viewing of the sun. When we talk about eclipse glasses, when we have eclipses, we always take out our eclipse glasses, either like really the glasses format or the viewers like this. But if you keep them safely, make sure they're not scratched, but you could, any day, you could go outside and observe the sun through those. And we found by doing that, we found that kids love seeing the sun, even when it's not an eclipse. So you could have a pair, like make sure you have one that's not scratched again. And you could, for younger kids, for example, you could hold it towards the sun and then the kids come one at a time to observe through. There is some danger, but I found that if you do it safely, then it's you would have to be like to do it on purpose to stare at the sun. And for most people, it's not comfortable at all staring at the sun. So I think if you do it safely, you make sure your glasses are not scratched, and it's completely safe to do that with the kids, making sure they just look through the glasses of the viewers. And it could be a fun activity to do outside on a clear day if you have a pair of eclipse glasses. So I'm just highlighting that as well there. It doesn't have to be on the equinox or the solstice, but I just thought I would mention it there, sort of ideas with the sun, for example. Okay, I don't see any questions, I think, but let me know if you have some. Now let's talk about some activities to get the kids moving, especially if you're doing interpretation of the kids outside. Make some good use of the space that you have around you. And I think some of the most basic activities which work very well are just to represent the motions of the earth. You get the kids to move to simulate either the motions of the earth on its own axis or around the sun. You can add the moon in there, that gets a lot of motion. You could even be, if you want to challenge, you could even try to do a whole solar system, a whole moving solar system. It won't be to scale in terms of distances, but you can have the sun in the center and then the other objects moving around. And hopefully you can get Mercury to go faster than Uranus and Neptune, for example. So if you have a field and a big space, that could be a fun activity to do. You can either, each kid could represent the celestial object with their own bodies, or they can use some balls to do that. I especially like the Earth ball, the one we see on the screen here and the one I have here. It's an inflatable ball. You can do a search online for Earth ball, and you can buy it in different science centers as well, and sometimes in the gift shop. But I think it works well. It's easy to carry and it's beautiful. It shows some clouds on it. It even glows in the dark. The cities will glow in the dark if you have it, but I really like it. So you can use it to represent the Earth. Or if the kids have use their own bodies for the celestial objects, you could have them create sort of a necklace, like they draw the moon, the sun, or the earth, and then you just make holes with a string, and they could have that to know which object they are as they move around. So different activities there. But that's just, motions of the earth. And actually even just the earth sort of have it spin on its own axis and then go around the sun. There's a lot you can add to it for people to really understand how things work. You could try, for example, to ask them, when they're facing the sun, for example, if I'm the earth and I'm facing the sun, then for people having that view, it would be noon because you're facing the sun directly. Now, if I turn around and the sun is on my back, then that would be midnight. But then you can ask them to try to represent, for example, sunrise, sunset, and then you can go even more challenged, like 2 p.m., for example, or 8 p.m. depending on the time of the year, the sun might be up or not. But that's it really gets them to think about it. You can try it yourself first. I think there's a lot of value in trying it first, understanding how it works as you move around the sun. In the sun-earth activity, for example, I also recommend putting other kids, for example, to represent stars all the way around. So why do we have some stars visible in the summer and some visible in the winter? Well, you can understand that as you're creating your model, because if some stars are in line with the sun from your perspective, then you don't see them at night, you see them during the day when the sun is in the field of view. But when it's 6 months later, then you will see those stars because you'll be on the other side of the sun. So that's a lot maybe for you to represent in your mind right now. Try it out, check that activity, sun-earth activity, and try it out. And I think there's a lot that could be taught there with very simple equipment, basically nothing, and they can get a better sense of the motions in the solar system. Oh yes, and eclipses. You could, like, for example, the picture we see here, they're trying to represent eclipses with the ball representing the moon and this, the Earth here. But I also like this activity here. You might have seen it before, where actually, oh, just lost the Earth, where you could get, this could be a meter stick. This is a version that folds, so it's easier to carry around. You'll see in the document, it shows where you can get it, but you have the Earth and the moon, and this is the Earth moon model to scale. And you realize when you're under the real sun, for example, as a source of light, if you try to create the shadow of the moon on the Earth, it's actually very hard to recreate solar eclipses. And that's why they're kind of rare, actually, because the alignment needs to be perfect. So this is a fun activity. It's not very expensive to get the materials for it. If you buy, especially the kit on a meter stick, for example, and this one is a hard little ball, but you can get just, again, styrofoam balls or Play-Doh. You make them about the right size and you could create that. So again, in the link for this activity, you'll have all the instructions for it. The other one I really like in this case, it's not so much to represent the motion, but to represent the scale, the distances. And you can create a solar system to scale in your neighborhood. If you could do your own calculations if you'd like, but we have a site. In fact, I'll take you there. On our website, you have this table here where you can either decide how big you want the sun to be, or you enter your own. So let's say I want it to be with an exercise ball, and it calculates the size of every other object. This is in millimeters. So you can see that they're all very, very small. And, you know, Jupiter in the scale would be 8 centimeters, but the Earth would only be less than 1 centimeter, actually. It gives you a size, an object. So if you can grab these objects beforehand, and then you walk around, you walk in your neighborhood and have a way to measure the distance. Worst case, you measure 1 step, 1 meter, which is not completely correct with kids, depending on the size of their legs. But anyway, it could be a good way to estimate it. And you can see how far you go to represent the whole system. And if you want, you can even map it. Let's say I'm going to do this very quickly. Somewhere in Montreal, for example, I could draw the orbits around where you are located. And now we're just seeing the orbits of the outer planets, so Saturn, Neptune, and so on. But you could see as you zoom in and out how big the solar system would be on that scale. And we've done that. Actually, over the winter, we tested that activity with many schools, and we had amazing pictures coming back, you know, and stories of the kids losing mercury a few times because they couldn't find it on their way back, right? They didn't know where to put it. It was too small. Some people even made signs on some of the posts in the streets, telephone poles, for example, and they put the signs there. So people afterwards could even see the solar system to scale in their neighborhood. So it's a great activity, again, that you could try and be outside, get the kids moving, and so on. Lots of learning while having a good time. And I want to finish with some crafts and some activity ideas quickly. Again, you have the link and you can go and learn more, but the pocket solar system, for me, it's very simple, but it's a simple but very powerful activity to learn the distances in the solar system. You take a strip of paper about 1 meter across, and The first time I did it, even though I knew the distances, the planets, doing it this way and click, when I say our version, actually, it's because it takes you to a PowerPoint. Well, actually, this is a PDF where, oh no, it's actually still a PowerPoint. But you can see how strange it is compared to what you would probably expect. So I won't give you all the details. Go check it out, but you might be surprised by where the planets are located in the solar system. If we start with the sun on one end and the Kuiper belt, or where Pluto roughly is as the end of our solar system. It's a model, it's not perfect. It actually puts all the planets and objects on a straight line. So that's not super representative, but just in terms of distances, it is very interesting. This one is not so much crafts actually, but it is an activity with different materials or props you could have. It's to understand the Earth-Moon distance using a standard globe for the Earth. And you have the moon, which is actually ends up being, if I remember right, 9 meters away. So it's actually always further than people imagine. We tend to imagine or visualize the Earth and the moon much closer than they really are. And what I did in this activity, which was important to me, is also to make people think, get people to think about our limited resources. So the amount of water that would be on the Earth, it's tiny. It's just a few millimeters on the scale. And it's surprising because we know the surface of the Earth is mostly water, but it's not very thick. So in terms of volume on the scale, it's very small. And that gets people to think about, oh, wow, there's not a whole lot of water on Earth overall. And the thickness of the atmosphere as well. So that's some powerful messages you can send in there. So again, the instructions are there if you want to check that. And this is one that blew my mind when I discovered it recently. So I really want to highlight it. I didn't invent it. And I want to give a big shout to Plateau Astro. Actually, Trevor from Plateau Astro did a fantastic job. He lives in Montreal and he does some activities. You can actually book his activities if you are in Montreal, but he also offers some activities online if you want to check his stuff. But what he did was an activity where you have the Earth and the moon as, again, I think he uses styrofoam balls. So that's pretty basic to create the model, the scale model. But then he uses augmented reality for the sun. So it only works on Apple devices for now. So you need to have an iPhone or an iPad. And augmented reality is that you look through the camera, so you see what's in your yard or wherever you are, but it adds something in the camera. So that's what we see here, and I'll play it. You can see that the field where he's located in Montreal, and the sun to scale appears through your camera, and he made a video of that. So what we'll see there in the little video is that, well, you have the big sun there that's obviously added. It's not real, but you will see a scale model of the Earth and the moon right there. And so that's the right distance from the Earth to the moon. Of course, it's not the right distance to the sun, but you can see how big the sun would be compared to your small Earth and moon. And I just love this idea. Like, for me, it kind of shows the power of augmented reality to show things to scale, which is very hard in astronomy. So I think if you had one device and you could do it in the field with a bunch of kids, that would be so fantastic. I just love it. So anyway, check it out. It has other great stuff online, and check out his stuff. Hold on. And I'm putting links to more activities. Plato planets. Again, this one compares the volumes to scale, and it's quite surprising. We also have a series of cards of the solar system objects, which could be great. The activity is sort of to classify them and understand it is very tricky because some objects don't seem to fit in the right categories with the other ones. But it's sort of trying to redo what scientists are doing, is always to classify objects, and the whole discussion about why Pluto went from being a planet to a dwarf planet could be added there. That's very interesting and rich as well to see how science is done. I like to say that objects, when we discover new objects, they don't have big labels on them saying, I'm a planet, I'm an asteroid. Scientists have to look at them and then see their characteristics and say, wait, what is it similar to? Do we have other objects like that? And sometimes our categories change because we're learning new things and we're discovering new objects. So that's a fun activity for that. So that's what I wanted to show you. There's a lot of content. Again, I will type again. Do I still have it? Yes, there we go. So in the chat, there's the link for the Google Slides. and I will send it with a recording. Oops, that's not what I wanted to do. I will send it to the recording as with the recording, so you'll have access to that later on. But there's a lot of, as you saw, there are many links on there, and feel free to browse through those activities. And if you have any questions, don't hesitate to contact me. I will stop sharing for now. If some of you are online with me have questions, I will take them. Actually, I'll let you the time to write them, but first I will stop the recording for those of you who were watching that. But thanks for staying till the end.